In this video, we're going to look at what's called measures of center. And to do that, we do have to consider some important characteristics when we're looking at the data. They're listed here at the top. They're the shape of the data, where the center of the data is, how spread out the data is, and outliers. So outliers, most of us are familiar with that phrase, are data that don't quite match the rest of the data. So this is data different from the rest. So that would be like if I went through and I asked everybody their income for the class. Okay. And there happened to be a millionaire in our class who just likes taking math classes at OCCC with me. That means then that data, that person is going to be very different from everybody else because most people are millionaires and therefore they would be an outlier. Okay. So we're going to take these scores and we're going to make a histogram. Now, they unfortunately weren't nice enough to us to put it in order. So we'd have to kind of take a second and look at the lowest data value. And to me, it looks like the lowest data value is 49. That actually happens to happen a couple times. But that means then that when I set up my histogram here, as I don't have a ton of space, I'm going to start with the 40s. And I'm going to kind of do what I did in the last section. I'm going to make the categories kind of go by grades in terms of the tens. So 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and then 90 to 100 would be the last category. All right, so I'm going to count them out. Looks like we have 2 in the 40s. And then let's see, there's 50s. Let's see. Oh, yeah. Okay. So here, 52 is 1. And then 58. That looks like that's it. 60s. So 1, 2, 3. 70s. 1, 2, 3, 4, 5. 80s. 1, 2, 3, 4, 5 again. And then the 90s are the 2 that are left, which is 2. All right. So let me just total this up real quick. Let's see. That's 10. It's 6. I'm getting 19 total. All right. So I'm going to draw this. Now, I'm after the shape of the histogram. So I'm kind of looking at what's going on when I examine this shape. So 40, 50, 60, 70, 80, 90, 100. Okay. And I'll go by ones. 1, 2, 3, 4, 5. I'll just throw 6 in there since I have enough space for it, even though I don't need it. All right. And these are the Math 95 exams. These are the scores. And then this is the frequency. I'm going to go ahead and abbreviate frequency because that's fine. Okay, so 2 for the first categories. And then we jump to 3. Then we jump to 5 for the next 2 categories. And then down to 2 again. And then I'm kind of trying to figure out the basic shape. So it looks like the majority of the class, right, scored from 70 to 90. So they got a C or a B. And what I'm kind of doing is I'm thinking of this shape almost as like a curve. So it's almost like I'm kind of looking at it as how it's doing this. That's kind of the basic idea. And I'm kind of seeing that the group is kind of more towards the top. I mean, there are a few at the bottom, but the vast majority is in the upper half of scores. So that tells me something about the shape. Since the majority of the students are in the upper region of the test, that means the majority of the students did well on the test. And we have names for that. So let me come down here and we're going to go ahead and give some names for the shapes and information about the modes. So something is unimodal, meaning it has only one mode. So that would mean if I were to draw the histogram, I'm just going to do a little rough sketch, there would be a big category and everything else would be smaller. Bimodal is obviously two modes. So in that case, my picture would work because I have two categories tied for the biggest. Oops. Here, I'll just kind of rough sketch it. Two there, and there. So that would be an example where we have two modes. Multimodals, obviously many modes, 3 or more. Oops, 3 or more modes. And that means we have a tie in multiple categories. So here, let's say it looks like this. Something like that. The idea being that there's 3 big categories. So histograms allows us to identify the mode and to know whether or not we have one or more modes. Okay, now in terms of the basic shape, we look at symmetries. So there's what's called symmetrical data, meaning where the data is grouped in the middle. So the majority of the data is here in the middle, and then the rest of the data is kind of off to the sides. That's the basic symmetric. Now, as you see, I didn't draw a perfectly symmetrical picture, but it's referring to the kind of curve that we have, this kind of bell-shaped curve. It can, by the way, symmetry can exist with 2 modes sometimes, but I'm not going to worry about that. This is more common. Skewed left. So as that kind of implies, it means that we have this kind of weird pulling off to the left. So it means that the data is actually centered on the right, kind of like our graph. The vast majority of the data is over here on the right. And then we have these kind of like small categories here on the left. And in that case, the skew is that we have this kind of pull to the left. Often, this might indicate that we have potential outliers. So skewed right is when the data is kind of all grouped up on the left, exact opposite. So it's all grouped up over here. And then we've got this data that kind of existing over here on the right that's skewing it to the right. So it's kind of like that. So again, we have potential outliers, but on the other side. Now, this phrase, the mean is less than the median, is implying that if we were to average out the scores, our mean is going to come out lower than the median. And the reason is if we have an outlier that's to the left, meaning smaller than the rest of the data, it's going to pull the data down when we include it in the mean. Whereas when we have it in the bigger than the rest of the data, an outlier to the right, it's going to make the mean bigger than it should be. It's pulling the data, okay? Whereas when it's symmetrical, the mean and the median are very close together. They're relatively equal. They're not exact, but they are, in basic mathematical terms, pretty close. So the mean, as most of us are aware, we often use the word average, by the way, is when you sum the data and then you divide by the total amount of data, which I'll say divide by total frequency. We'll use that fancy word frequency. And the word total here, sorry, looks kind of sad. Let me fix it. Total, there we go. That's better. All right. When we find the median, what we're looking for is the middle value. But when we have an odd number of values, that's very easy to do. We would just find literally the middle number. And this is, by the way, when the data is in order from smallest to biggest. With the even values, we're going to take the average of the middle two. The mode is the most frequently occurring. And up here, when I was kind of talking about the mode, that's what I was referring to, the largest categories. So I kind of used the phrase knowing that most of us have seen mean, median, and mode at some point, and hoping, of course, that you remembered that. All right, so let's go ahead and take the data and put it in order, and we're going to find all of these for this data. Now, I put it in order for you, but I would love you to pause the video, put it in order, and make sure yours matches. That kind of practice will help make certain that you can do it by yourself. Okay, so let's do this in order here. Let me give myself a little bit more. All right, so this will be 49 twice, and then 52 and 58, 62, 66, 67, 71, 73, 74, 75, 78, 81, 82, 84, 85, 86, 91, and 96. And I'm just going to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yay, we got them all. Okay, so to find the mean, I'm going to add these all together. Pause the video, add them all together, and see if you got what I got. When I added them, I got 1,379. And then I'm going to divide that by 19. And in my calculator, I get 72.6. Okay, so for the median, I'm going to find the middle number, which means since there's 19 pieces of data, I'm going to count 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. So here is my 9th term. And then I should have 8 on the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What? Oh, actually, I want to count 9. Just kidding. So 74 would be the middle data. Oh, Alexa, stop talking. Sorry. I have a thing in the room that thought I was talking to her. All right, there we go. So 74 is the middle data value. I'm going to actually have 9 on either end, not 8. What a dork. So 74. Now, notice, by the way, 74, 72.6, pretty close together, not too far apart. The mode, however, is 49. And that doesn't match really the other scores. When the data is symmetric, all 3 of these are very close together. But when the data is possibly skewed, they aren't. And we did know our data was a little bit skewed, right? We up here in our graph, we knew that it was left skewed, meaning that the median is going to be higher than the mean, which is what happened. Okay, the median is higher than the mean, and then our mode ended up being actually the physical number 49. Though category wise, we're kind of seeing that it's the 2 categories that the 70 to 80 and then 80 to 90 range are the largest categories in terms of frequency. So mode is kind of helpful, but not nearly as helpful as the mean and the median. It just kind of helps gives us information about whether or not how our data is possibly skewed. And the mean and the median do help us see that information.